Hi everyone, very good morning and good evening. So we'll start the session. Let me share my screen, guys. Just 1 second. Okay, so good. So in the previous session, what we have done, we discussed about task implementation, right? So we saw the how to perform a task, how to implement the sorry dependency management. So how to schedule, how to assign the task to specific virtual warehouse. Today, what we are going to do is we are going to see about so how to work with capture data change. This particular thing we will call it as streams. Here capture data change or streams. Let's say if you want to understand DML changes performing on your table, then we can able to see with the help of streams. DML changes means like insert, right, and update and delete, right? All these changes we will call it as a DML changes. When you are doing DML commands on your table like insert, update, delete, if you want to understand which operation performed on a table, we need to know that. Then we can use these streams. In time travel, what you can able to get it, we can go to the specific period of time and then we can get that information, right? That is time travel. We can see at that particular period of time what is available, we can able to see by using time travel. But we cannot able to capture the DML changes, what it is exactly performed on the table. We don't have that option, right? To implement any DML changes we are going to perform on those particular tables, what we need to do is we have to work with the streams. When you are working with the streams, what it is going to do is stream is going to understand which change you performed on a source table. For example, you have source table, nothing but let's assume your EMP table. In employee table, you are performing like today you are going to insert, tomorrow you are going to update, next you are going to delete. But you wanted to capture all the changes, what exactly you are doing on the table, DML change. For example, let's say if you take about our bank account, we wanted to know whether the transactions, right? Whether it is a deposit, credit or debit or online transaction, right? This kind of information we need to get it. So where you can able to get it, if you see the bank statement, you can able to see that information, right? So whether it is a transaction belongs to credit or debit or what is the transaction you have performed, you can able to see that information in the bank statement, right? The same way here what we want to do is we wanted to capture the changes what exactly performing on the table to maintain history, to understand. So in a future, so we need to understand what exactly happening on the table. I wanted to know that. For example, let's assume in employee table we have the employee details. Employees salary may change, right? Whenever the salary has been changed, now we wanted to capture that in another target table. What is the previous salary? Maybe the employees, maybe today it is today they are available, maybe tomorrow they will move out from the organization. We wanted to maintain in another table whoever moved out from the organization, we wanted to keep that as a history. So these kind of whatever the changes we are performing on the table, if you wanted to capture and you wanted to maintain this in a separate table for our reference purpose, then we will come with a streams. This is nothing but capture data changes we can able to perform on the table. Now here when you are working with the streams, when you are creating a stream, right, stream is going to create additionally three additional columns. stream will create. You no need to do anything. Automatically stream is going to create 3 additional columns. Those are metadata, $action, and metadata dollar is update, and metadata dollar row id. These are the 3 additional columns stream is going to create. Based on this, we can understand which one belongs to insert or delete, which one is belongs to update transaction, which one is belongs to, this is the row id related to specific transaction. We can understand based on the row id. We will come to that. Now, based on this, we can understand what exactly performed on the table. We will come to know. One more thing is, stream is going to capture this data, right? This data, it will be available in a stream until you utilize the stream. If you utilize stream, it will reset. It will reset. It means whatever it has been captured, those details will be reset to the initial level. It means the data will not be available in a stream if you utilize the data. Utilizing means nothing but if you consume the data from a stream. You are picking the data from stream and then you are inserting into another table. That is nothing but a consume. Or when you are utilizing, or we will call it as a consume the data. Utilize or consume data from stream, it is going to reset. By default, it is going to reset. Once it is reset, the old data will not be available. That's the reason what you can do is, before it is resetting, or if you don't reset, I mean, if you don't utilize, what will happen is stream is going to keep only 14 days data. It will be available on a stream. That's it. Older than 14 days data, it will be removed from the stream. It will not maintain. For example, you wanted to maintain permanently the changes. Whatever the changes happen, I wanted to capture that into a other table permanently. Then what we can do is we can keep a target table. We can load all this, the changes data from the stream. We can keep it in a other target table so that we will have the complete history. It will be available. So in, if you keep it in a stream, what will happen? 14 days older, it will be removed. That's why we don't want it to give. For example, whenever the employee moved out from the organization, we wanted to maintain his complete history. How many employees has been moved out from the organization? We wanted to keep this complete history. So then, so if you wanted to implement that, then what you can do, we can keep that, pick the data from a stream. We can keep the data in a separate target table. For example, employees newly joined in the organization this year, we wanted to keep that as a separately in the other target table. We can do that. Employees who is like salary has been updated, their designation has been updated. We wanted to understand what is the salary before, like increment, what is the designation before the increment. In the source table, if you understand, you will see the only the final data. That's it, right? If you are doing any update, insert or delete, this table will be like updated, and then you can see only the final data. You cannot see your what happened exactly in the backend, right? To capture these changes, whatever the DML changes we are performing, we are going to create a stream. This stream data, if you wanted to capture separately for our historical purpose, you will load the data to the separate target table. That is the main intention of a streams here. Stream, or we will call it as a capture data changes. Now, when it is coming to the stream implementation, right? What we will do is we will create, observe this one. What we are going to do is we will create a source table, employees source table here. When on this table we will perform the changes, then we will see how the stream behavior. We are creating a source table with ID, salary, manager ID. 3 columns we are taking here. Let's take 3 columns here. Now, based on this source table data, What we are going to do is, now if you observe, see this one, select star from, this is the source table, right? Now see this, what you can see it here. You can see ID, salary, manager ID, only 3 columns. Now when I create a stream on this source table, it will have, along with 3 columns, 3 additional columns will be created. Now observe this one. We are going to create a stream on our source table. See this, we are creating a stream. What is the stream name? This is a stream name. Create stream, stream name on table. Which table we are performing? On this source table. When we create a stream on this source table, observe this one, what you observe here. Let's see the stream, sorry, this is a source table. Now let's observe the stream. This is the stream, right? Now give it here. Now let's execute this. What you can able to see, ID, salary, manager ID, along with, see this one, metadata dollar action, metadata dollar is update, metadata dollar row ID. These 3 columns will be created by default when you create a stream. Remember this. This is one of your certification question and interview question. What all the 3 additional columns will be created? Metadata dollar action, metadata dollar is update, and row ID. What is the purpose of these columns? We will see that now. These columns will be created. Now, when you create a stream on the source table, what will happen is, whatever you are going to perform on this source table, DML changes like insert, update, delete, whatever it may be, those changes will be captured in the stream. Those changes will be available in the table. At the same time, you can able to see those changes in the stream object. Now observe this. What we are going to do is, this is the source table, right? Now I wanted to insert some data into the source table. Some rows I wanted to insert it. Let me, what I will do is, first 3 I will pick it. First 3 I'm going to pick 3 values. So these are stream. We are inserting 3 rows. We are inserting data into source table. Now observe the source table. What we can see? We can see the data ID, salary, manager ID. These 3 rows, it is available in the stream, sorry, source table. Now check the data in the stream, what it contains. Observe this. See this one. Along with these 3 columns, observe the metadata dollar action. It is telling that these are inserted transactions. These are inserted transaction. Observe metadata is update. What it is telling? It is telling that this is false. It is telling this is false, right? It means metadata dollar is update false means it is telling this is not related to updated entry. These are insert entry only. And at the same time, if you observe here, metadata dollar row ID concept here, the row ID, if you see the row ID, see this row ID, all are unique. This row ID is unique. There is no duplicate, right? This row ID. Based on this row ID, we can understand this each and every row is a separate transaction. We can understand that this is separate transaction. Now, we have this data in our stream, right? If you keep like this, the stream, it is going to keep on updating the changes, whatever you are going to do it in a source table. 14 days older data will be removed from the stream. It will not be available. The behavior of the stream is like that. 14 days older data, it will be removed. Let's say, for example, I wanted to, these are the new employees joined in the organization this year. I wanted to maintain separate table to understand the employees who joined in this particular year, new employees joined this particular year. Then if I don't pick the data from the stream and then if I upload it in the separate table, then I can lose this data from the stream. We cannot able to understand. To maintain that history, what I will do is from the stream, I will pick the data, nothing but I will consume the data. We will utilize the data from the stream. We are going to load the data to other target table. Then in the target table, once the data is loaded, it will be permanently available. So even the stream data is reset, even the stream data is gone, you can able to see your historical changes in your, whatever the changes you performed on this table, you can able to see the changes in a other target table, right? For that, what we are going to do is we will create a new target table like this. I will create new target table. This is for new employees, right? What I will do is consume employee underscore. I will give the name convention as new underscore 2025. Just for example, I have taken this. So this year new employees who joined in the organization, I wanted to keep all the new employees in this particular table. Now let's observe this one. I created a new table. Now we wanted to insert the data into this table, right? From where we wanted to insert the data into this table? We want to insert all the new employees data from this particular stream. I wanted to insert into other table. Now if you wanted to insert, observe this one, insert into, what we are performing is insert into, this is a table, from where select from stream object. We are picking the data from the stream and then we are going to insert the data into the table. See this, when you use just select statement, it won't impact anything on the stream. But if you utilize the data, if you consume the data from this and then we are inserting into other table, if I do this complete statement, we are picking the data from a stream, we are inserting into other table, then this stream will reset. Observe this one. Now we have inserted the data. Where we have inserted the data? Into this particular table. This is our target table. This is our target table. For only the employees newly joined organization, they can able to see the data here. Now observe the stream data. What happened? Stream data, see this, stream data is it's gone, it is reset is done. Now if you observe the source data, what you can able to see, you can see the data, the same, it has been updated into this one. Now this is for insert, right? For example, maybe like on this particular thing, if I delete something from a stream, let's observe this. For any one particular row, I'm going to delete it. Let's say here we have inserted, we will delete. Observe this one, delete from table. What is the table? Main source table. This is the table, right? Delete from table, where we will pick employee ID equal to 101. So what we are doing here, we are deleting the data from this particular source table. So it means, let's assume employee moved out from the organization. We are deleting from the source table. Now when you deleted from the source table, see this one row has been deleted. Now what you can able to see in the source side, see this, observe this one, data is gone, right? But if you observe the stream will capture that. See this one, what you can understand, metadata $action. You can see that this is a delete. This is delete entry, right? Now this delete entry, we have the data here. Now I wanted to, employees who moved out from the organization, I wanted to maintain in a separate table for understanding purpose. I wanted to see this year how many employees moved out from the organization. Then what you can do, if you wanted to preserve that, the data is available in a stream, We will create a new target table like this. For example, we will create new target table. Let's say this is employees moved out from the organization, delete employees, deleted in this year. Let's assume that. Or I will give it as delete. Okay, employees, table name is employees delete, who is moved out from the organization. So we are going to create a new target table. Now the deleted entry, where it is available? It is available in the stream. In the stream. See this stream, we can see that. Now this entry we wanted to keep it in a separate target table, right? In this target table we wanted to keep. Then what we can do? We can insert the data from the stream, and then we will keep it separately as a data in that another target table as a delete entry. Now if you observe this particular target employee delete, you can see all the deleted entries in this particular. Then we can understand, okay, these all the employees has been moved out from the organization. See this one from this particular table. If you see, you can see this employee has been moved out from the organization. But can you able to see the entry in the source table? No, right? But where you can see the deleted employees? Here. Where you can see the new employees in that particular year? Here. Right? Now the same way, let's assume what I am going to do is I am going to update here. See this carefully. On this particular topic we will get the certification question and interview question also. Update the table, source table, set. I will update salary. I'm updating salary equal to where will take employee ID 102. I will take 102. Observe this carefully here. How many rows we have for 102 in the source table? Only one, right? If I update, what will happen? This particular salary will be 20,000 will be updated with all lines, right? See this here. Now see this number of rows updated. What you can see, one. Number of rows updated is one. Now check the data in the source table. This is the source, right? What happened to the salary? It's updated. Now observe the stream. Here it is very important. The observe the behavior of the stream now. Only one entry, right? It has been updated. Only one row updated in the source. But what you can see that in a stream, observe, you can see two entries here. This is because of behavior of the storage layer in our Snowflake. Snowflake, it is going to store the data in the form of micro partitions. It will be in the form of file formats. It will be in form of file formats. So when you are updating something, it won't update the existing file. It will remove the previous file. On top of that, it will create a new entry. See this one? You can see 102. See this metadata $action delete. Observe this 20,000 deleted. This value, all nines, has been inserted. We can see that. But one more thing, okay, it is deleted this entry. It is inserted this one. Fine. But when we are inserting also, we will have a insert entry. When you deleted also, we will have a delete entry. Then how you will understand which one is delete, which one is for update, which one is for delete? Let's say, for example, what I will do is I am not consuming any data from the stream. We will update some values here. All fives I will update it to understand this. Now I am inserting one row. See this one? I am inserting. I have inserted, right? One has been inserted. Same way, I will insert one more. Let me change this one. All six. Now what happened? All six has been inserted. One more I have inserted, right? Inserted. Now I will delete 103. So which one we have deleted previously? 103 we have deleted. Now 101. Now I am going to delete 103. Two inserts I have done, one delete I am doing. Before that we have done one update, right? Now one deleted. Now see the source table. Observe the source table. What you have? This is your final data. See this one? This is inserted. This is inserted. 103 is deleted. This is updated. This is your final data in your table, right? Now observe the stream. What you can see in the stream? See this, how many entries we have? Insert, delete. Okay. For update also we have insert and delete. But how come, you will understand this transaction is belongs to update. Simple thing here. Observe the metadata dollar is update column. When you observe this metadata dollar is update column, when you have the values of metadata dollar is update, if it is true, see this one. When you have the value of true in metadata dollar is update, that we will call this as updated entry. See this, one is insert, one is delete, but this is updated. This transaction happened for the updated. At the same time, you may have multiple updates for the different rows. How you will understand this transaction belongs to the same one? These two belongs to the same one. Now observe this one. We can see it here. See this. By seeing these two values, last metadata dollar row ID, we can say that these two row IDs belongs to same, right? These are the same row ID. So we can say that these two belongs to single transaction. If I do another update, I will get again true, insert, delete, and different row IDs will be there. Both will be the same. So that we can understand which one is belongs to which particular transaction. That's the reason we required metadata dollar row ID here. Clear? And how you will understand this entries belongs to update? We can understand that this entries belongs to, see this here, these are the true. So we can understand this belongs to update. One more thing here, when you are performing this, right? If I consume even single row from this particular stream, complete stream is going to reset, guys. Even if you consume single row from a stream, complete stream is going to reset. Remember this one. Then how we will manage all the different the purpose, like insert separately, delete separately, update separately. I will show you. So how to overcome this. But behavior of the stream, understand, even if you consume single row from a stream, this complete stream data is going to reset. Now let's assume now we have this data, right? Now I wanted to maintain before update, what is the salary for that employee? Maybe the manager wanted to understand before giving the next hike. He wanted to understand, he wanted to see before like this, what is the salary has he contains. This is the current salary. What is the previous salary? I wanted to compare with the previous salary. Then only I will decide for the current year hike. In that case, what we can do? We need that before salary, it has to be in a separate table, right? Now, if you see your source data, you can see the current salary. You can see the current salary, current details. That's it. This is the current salary, right? Before update, what is the salary? Do you have that information here? No, we don't have the information. Now I wanted to keep it separately. For that, what we will do is we will create a separate table. Let me come here. We will create separate table. I will give before update, before update, the salary before update. Now, which one is the before update salary? Now the table, target table is created. Now, if you observe the stream, how you will capture this? Let me see the stream data. Now this is the stream data, right? This is Stream data now. What is the salary before update here? If you observe this, which one is belongs to update? True. This true belongs to update. What is the before salary? This is the salary, right? How you will pick only this one? See this. Metadata dollar is update true. Metadata dollar action is delete. It says that this is the salary before update, right? This is the old salary for this particular 102 employee before updating to all nines. This is the salary. If I want to pick only one this particular row, then what I have to do? I can give a condition statement, right? So previously what we are doing, insert into this one we are doing same way. I will give insert into, see this, this is the table. We are going to keep that in the other target table. Here we will give where condition, where, how to pick this metadata dollar is update, right? Metadata dollar is update. Let me pick this column. Metadata dollar is update equal to, what is this? True, right? And what is the other one? Metadata dollar action. Metadata dollar action equal to, what is this? Delete, right? Then we can consider this related to delete transaction. Then how many rows it will be picked and then it will be loaded to this table? Only one, right? Only one row we are going to pick, this row. What about the other rows? It will not be available in a stream. It is going to reset. Observe this one. What will happen now? Sorry, this RUA. Okay. Now let's come here. Execute this. Observe this one. How many rows inserted into this particular target table? Only one, right? See this, select star from this particular target table. This is the, now what you understand, in this particular table we have before update, what is the salary here? You can see all the current salaries in the current employee table, and then before update salaries you can able to see that in the this particular target table. And then like whatever the new employees came to this one, it will be we are updating into another target table as insert. And deleted entries we are keeping in a separate target table, right? All we are separating, all the removed employees in one target table, all the updated employees into one target table, I mean salary updated into one other target table, right? Like that we are separating. And if you observe here one thing, we picked only one row from the stream, right? Now if you see the stream data, see this, observe the stream, what happened? Stream became reset, it's gone, right? The data is not available. Even if you pick only one row from a stream, it reset all the entries. Then how you will going to manage all the details like insert, update, delete? If you wanted to perform into separately, how we will manage this? So what is a scenario? For example, so EMP, suppose, observe this EMP table, we have a stream and we are going to load this to target underscore insert for the new data. Same stream, we will create a stream name on the same source table, the same stream, the target underscore update before update value. Same thing, I want entries related to delete, right? The target underscore delete. I wanted to maintain all this data into the three target tables. Now observe, we have done the changes on the EMP table like inserted, updated, deleted, whatever it may be. Now, if I utilize the stream for this particular target, what will happen to the stream? Stream will become empty, right? Then how you will understand deleted entries? This is gone. How you will understand inserted entries? This is also it is gone, because when you consume this, what you are understanding, the stream is going to reset. When the stream reset, the complete data is gone in the stream, right? It is not available. So in this particular situation, the solution is, what we can do is, instead of creating a single stream on your table, you can create on the same table, you can create separate stream names. For example, stream underscore, this is for insert stream. This I will create another stream called update stream. Another stream I will create it called delete stream. Now what will happen? Three separate streams on a single table. There is no limitation, guys. We can create multiple streams on a single table. Then what will happen is, every stream, when the data is updating in a table, all the streams will capture the changes. When you are performing delete, only you are going to utilize this stream only. Remaining streams, you will have the entries related to delete, entries related to update and insert. For example, when I am picking only for the updated values from this particular stream, remaining stream will have a data, it will not be reset. This stream only it will reset, because separately I am using this stream for only for the updated entries to capture. Separately I am using this stream only for the deleted entries. Same way this is for the insert entries. Like that, single table, source table, we can create multiple streams, and individually, based on our requirement, we can use it. Most of the time, right, this stream we are going to use when you are working with slowly changing dimension. I wanted to capture complete history, I want to compare with the source, I wanted to load the data to the target table. By using task and streams implementation, going forward we are going to see end-to-end implementation of slowly changing dimension. So at that particular time we will see, so what is the actual purpose of the stream, so how we can able to utilize it. By seeing this metadata dollar actions, metadata dollar is update values, we can able to identify new one, updated one. Based on that, we will maintain slowly changing dimension implementation in historical target table. So for that, we will use most of the time stream to capture the changes. The changes will be available here. Based on that, we can able to implement the further logic. Now here, one thing we need to remember, stream is going to reset when you utilize it, right? Even if you utilize one row, complete stream is going to reset. And at the same time, one more thing we need to understand, stream will capture the changes only when your transaction is committed. If it is committed, transaction is commit. So till today, we didn't discuss about this commit. Commit means nothing but a saving operation in a database, nothing but save. When your transaction is commit, if it is saved, then only stream is going to capture the changes. Otherwise, if your transaction is not commit, then it will not capture the changes. Remember this. Now here, Snowflake, right, it is a auto commit. You no need to use commit like in other databases. If you insert, update, delete any DML changes, if you're done, you need to use a commit, then only that operation is going to be saved. But here in Snowflake, by default it will be auto commit. You no need to specify, I don't want her to do auto commit. Then there is an option. What you can do is, you can use begin statement, transaction statement called begin. Now within this begin, you can perform the transactions, you can perform the statements. Until you commit, it will not be saved. Before commit, we can do rollback. Rollback means it is going to undo your transaction. Now observe this one. I'm going to use, for example, let's see, do you have any data in the stream now? This is the stream, right? Do you have any data in the stream? No, right? How many rows we have there in a source table? 3 rows. Now what I will do is, I'm going to use begin transaction. Observe this. I have used begin. Now I'm going to insert one new row here. Let's say I will pick all nines here. Nines I am taking here. This row I am inserting. See this one? This row I am inserting now into the source table. Now we have inserted. Now after the begin, we executed that statement, right? Now if you check the data in the source table, see this new row inserted, right? Now check the data in the stream. Can you able to see the entry? No, right? I cannot able to see that entry. What happened here? The reason is it is not committed. See this one? If I use rollback, now I am using rollback. Now I used rollback. Now check the data in the source table. Previously the row is available. See this? Row is gone because it is not committed. When I use commit, then only that operation is going to save. That insert is going to save. But here, before commit, we have done rollback. Rollback is nothing but undo operation. It is not going to be saved. Now here, let's observe this. What I will do is again, let's say I will use begin. I'm going to insert it again. We are going to insert it again. Now I will use commit. Once it is committed, once committed means nothing but saved. Now I have used commit. It is done. Once it is committed, if you do rollback also, it won't work. Once it is committed, nothing but it is saved. You cannot do any rollback. See this one? Now we can able to see row and then observe the stream. What you can see, stream we can see this, right? Now it is captured. Remember, this stream is going to capture only the committed transactions. Now because this is committed, so we can able to see that. Now if I do rollback here now, see this? If I do rollback, now I have done a rollback. Rollback is done successfully. Still I can able to see the entry because it is committed, because this is saved. So you can able to see that entry in the stream because this is a saved, right? Once it is saved, if you do rollback also, it won't work. So generally, right? So when you are doing something as per the best practices, what we are going to do is when you are working on worksheet. So when you are starting a day, so always we will start with the begin and then so we will do our operations. We will write our queries. If you are like confirmed, once you cross checked one or two times, then only you can able to commit. So once it is committed, we cannot roll back. So if you wanted to roll back, you can do rollback before that commit, right? It's up to us. So this is the transactions it is available. If you want, if you don't want auto commit in our Snowflake, then we can use begin transaction. But remember, Snowflake, the transactions are auto committed. DML changes are auto committed. And one more thing, stream is going to capture the changes only once it is committed, right? Then only stream is going to capture the changes. Now in this particular stream, we need to understand that even single row, if you capture, if you utilize it, stream will become reset, right? So under the same time, it will capture metadata dollar action, metadata dollar is update values. By seeing this, we can understand which one is the new one, which one is the old one. For updated entries, each update you will have two entries in your stream. Remember this, one is insert, one is delete. For metadata dollar action, what is the value for the metadata dollar is update, that will be true. If it is true means that transaction belongs to update transaction. Based on this, we can able to understand what exactly is happening in the source table. See this, if you observe source table, what you can see it here in the source table, we can see your final, I mean sorry, This is our source table. You can see this is your final data, right? Finally we have 4 rows, but we have done so many transactions on this. We have done update, we have done delete, we have done again inserted multiple times, right? But where these transactions are capturing, we are capturing separately in a different target tables, right? To understand what is happening on my source table. In those particular situations, we are going to utilize the streams concept. This we will call it as a change data capture. Whenever the change is happening on the source, we are capturing the changes, and then we are keeping that entry for our the purpose of business. So requirement, we can able to understand it. For that, we will use this. Based on this, we can able to work with incremental logic. We can able to work with slowly changing the dimension logic. We can able to perform based on the streams concept only. Going forward, we are going to work on those things. Now let's come to the questions. I can see, let me come to this. How we will know the latest update if the multiple updates is done for the same employee? Yeah. So when it is coming to, right, if you have done multiple updates for the same thing, always it is going to capture the latest update only. Latest one only you can able to see that in a stream. You cannot see at the same time before like implementing the stream. If you update multiple times, what will happen is it is going to have the latest update. Always it will pick the latest update, and then you can able to see that. That is one of the drawback of the stream. We can see only the latest updates. The time travel work on a stream data. Yeah, when it is coming to the streams, right, what will happen is how many days you have the changes. Based on that it will happen, but the time travel is applicable only for the table, not for the stream, guys. So because we are performing the changes on a table, right? So changes will be happen on the source table only. Can we change the stream default? Not possible, Venkata, not possible. By default, it is 14 days. We cannot able to do that because what will happen is if you change it, right, have a lot of the data in the backend versioning, so that storage will be increased. That's the reason it is by default 14 days. It is going to go for the like reset. There is no limitation. We can create a number. That is not a problem. Yes, we have to give it in a like this. We have to give. So we have given, right. So for example, if I don't give also, let's observe. Say this. I'm not giving. If I run this, say this one, it will not accept. So it will be considered as a string here, the true or false. So for example, let's say I'm going to give it for a true. So set true. Let's observe this. Say this. In a copy command also we have observed, right? So true or false. For the true or false, we didn't given anything. If you give also, there is no issues. So for the strings we have to give. For the boolean, it is not mandatory. Say this, it will work. Okay, good one. So yes, exactly, Rahul. So when it is coming to the streams in Oracle, so we have a trigger concept. Any insert operation happen, we need to get a trigger. Any update operation happen, trigger. Delete operation, trigger, right? With the help of streams and task, we can like have a trigger concept. So here in Snowflake we don't have a trigger. The equivalent concept is our change data capture, our streams concept.
But then the sorry, this is Ankit. So, but then streams is like confined to the DML operations only, right? Triggers can be on other operations as well, like database shutdown and all those stuff, right?
Okay, so streams only for the DML operations, correct? Not for the other things. A CD type one which will have the later. Yes, we can consider that, Kalyani. In the always so the source table, it contains the SCD type one. It will have the latest data only. Yeah, that is true. Is there any exception handling concept tracing the errors? Yes, we can able to do that, Mohan. So with the help of begin and end statement, we can perform the exception handling also. That is possible. Uh, I will show you this concept also in the coming sessions, how to implement this exception handling. No, not possible. No, Ankit. Row ID concept is not available in Snowflake. In Oracle database, we have a row ID concept, but here row ID concept is not available. The stream row ID is completely different. Don't compare with the row ID in the other thing. So in generally, the row ID will be a unique concept. Unique IDs will be generated for every row. But here, the row ID is a this related to capturing the changes. This row ID can be duplicated here in our Snowflake. This is a different row ID. We cannot compare the row ID with other database. Multiple columns update for those. Yes, we can do that. There is no restriction, Kalyani. We can do that. Yeah, when it is coming to multiple updates, right? So which column it is going to update? So based on that particular column, you will have a separate row ID concept. For example, here you are updating for any specific. Let me show you the data here. Okay. Now we have updated for. Sorry, see the data. Employee ID I have updated. Employee ID if I update, so that row ID will be separate for the employee ID transaction. I will update for the salary column for any other value. For that, the separate row ID will be created. If I update for the manager ID, separate row ID will be created. Everything will be a unique transactions will be available when you update for the different columns. So based on that, we can understand.
Then we will have 6 entries, right?
Exactly. Yes. Every update, you will have 2 entries.
Okay. Then how will it know which is the,
Mm.
uh, for example, if we are doing in a sequence, right?
Mhm, mhm,
We are
mhm,
doing an employee ID
mm,
update, next
mm.
manager update, next salary update. Then
That we cannot able to understand. Uh, there is no option for the sequence understanding. Then what you can do is whenever the update happened, immediately you need to run a stream without the performing the other thing. Then only we can able to do that. When it is coming to the like other question, when it is coming to the row ID concept, right? Row ID will understand so which transaction it belongs to. One update will have separate row ID. One insert, one delete will be there. Other update will have separate row ID. Based on the row IDs, we can understand that particular transaction belongs to specific update. That's the reason we have a row ID Venkat here. So practice it 1 or 2 times. So this is a
Dinesh,
very
you
like
said
good
that
concept, and then you will get confused. Okay, so practice 1 or 2 times. Then again we will discuss on the same concept if you have any doubts also. Yes, Venkat, I was telling something.
so you said that row ID can be duplicated. So when it
Hmm.
is duplicated, how can we identify the uniqueness?
Duplicated for only for one transaction only, right? Let me show you. We saw this, right? 102. I will pick it for example. Okay. So what I am doing here, I am updating. So for how many updates happen? Only one, right?
Mm.
Now check the data in the source. What happened to this? It has been updated for 555. It has been updated. And observe the stream. What you observed here? How many entries? 2 entries. This is the old value. This is the new value. Observe the row ID. I mean to say duplicate means this one. Say this one. By seeing this, these two are belongs to single transaction. Got it right?
Mhm.
Because of the
Yes.
single transaction, it creates so that we can understand. Okay, these two belongs to single. So this delete is for older record. This is a new record.
Mm.
So that we can understand.
Okay.
Clear, right? Yeah.
Mm. Yeah. Thank you.
Yes, we can implement it. That I will show you. So when we are implementing a task, right, we can schedule it for the specific period of time. And at the same time, whenever the stream has a data, your task is going to be executed. That is the interrelation between these two things. Based on that, we can able to perform the implementation. We can do that.
Manish, I have a couple of questions from the previous session.
Yeah, I can tell
Um,
you.
so we talked about the types of
Mm,
tables, right? Transient,
mm,
permanent, and temporary. So
correct.
can we
Mm.
move from one to other? Like if I've created a transient, can I move to permanent or to
Higher
temporary?
level, it is not possible. Lower level, you
Okay.
can do that. It means moving means it is not like don't think that you are completely like uh, for example, let's say you have a permanent table, you
Mm.
wanted to completely remove the permanent and then on place of that you wanted to replace temporary. That is not possible. That is not a moving. Don't misunderstand. You have a permanent
Mm.
table. From that you can create another table as a transient table.
Okay.
Permanent table also it will be there. You will create another table with the same data as a transient. That is possible. That is a
We cannot
creation.
alter it. We
No,
cannot alter it to change it to.
you
Okay.
cannot do that. That is not possible.
Okay. And my second question is right that you mentioned that the retention period starts from
Mm,
the day of creation of the table,
correct.
right?
Exactly.
But then if suppose after 1 year we have a table,
Mm,
right? From
mm,
like, and if I
okay.
want to see the previous
Mm,
like 90 days, right? 90 days is maximum retention period. So
mm,
if I
mm,
want to see the last
mm,
90 days data,
mm.
will I be able to do it, or it's only restricted from the day of creation only?
You can able to see older data also in the table. You can able to see, but when it is coming to the retention period, that is all over
Mm.
altogether different concept, right? You can
Right.
see up to 90 days from every time. For example, you even if you are the time travel also travel with you, right? So for example, today I can able to see past 90 days. Next month again I can able to see past 90 days. Next year
Past
also
90 days.
from that
Mm.
I can see past 90. For example, let's say bank statement. If you today if you wanted to download your bank statement only 3 months, maybe if you try for next year also, last 3 months only you can able to download, right? It doesn't matter. So how many from that
Okay.
particular day past 90 days. That's how the time travel is work.
Got it. Thank you.
Yeah. Any other questions? Okay, guys. Thank you. See you tomorrow. Thank you all for your time.